In this lesson, we're going to look at x-intercepts. We're going to define them and learn how to find them from an equation and a graph. So intercepts are where our graph of our line, or it could be a curved graph, whatever it is, our intercepts are where that graph crosses the x and the y axis. So we have on every coordinate grid an x-axis and a y-axis. So the point where your line crosses your x-axis is your x-intercept. And the point where your graph crosses your y-axis is your y-intercept. So in this example, if we were asked to find the y-intercept of our graph, we would look at where our line is crossing the y-axis. And that is at the point, we don't move on the x, so that's 0 for x and 2 for y. So that's the point 0, 2. For our x-intercept, where our line crosses the x-axis, we'll notice that we move over 1, but we don't move up or down. So that's the point 1, 0. Notice that intercepts have 0 as one of the coordinates of the ordered pair, and that will always hold true, because for it to be an intercept, it means you did not move up or down if you're looking at the x-axis, or you didn't move side to side if you're looking at the y-axis. So one of those will always be 0. So learning which one's 0 will be very important with intercepts. So our x-intercept is where our graph crosses the x-axis. So as I was just talking about, x-intercepts always have the y value of 0, meaning that we don't move up or down to graph the point. So if we're just looking at the equation of this line, 2x equals y plus 3, we certainly could graph that equation to find the x-intercept visually. However, if we know that the y value is 0, what we can do instead is substitute 0 for y and solve for x. So instead of y, let's replace y with 0, and it would be good to have parentheses around what we're substituting in. Simplify and solve for x. So we're going to divide both sides by 2 to get x by itself. So we get x to equal 3 halves. You can write it as 1.5. Either way is fine. And, sorry, my dog is barking. Okay, and so to write that x-intercept as a point, because y was 0 and we found x to be 1.5, or 1.5, we would write the ordered pair as 1.5 comma 0. Now what's really important is if you're being asked to find an x-intercept, an x-intercept is a point. So your answer should be written as an ordered pair, so meaning it's in parentheses with a comma, as a point. So you are not done by saying x equals 1/2. You must write that intercept as a point. All right, for that same equation, let's find the y-intercept. The y-intercept's where it crosses the y-axis, meaning that the x value is always 0 because you're not moving side to side on the grid. So to find the y-intercept of 2x equals y plus 3, this time we're going to replace x with 0 to find the value of y in that scenario. So 2 times 0 is 0, equal to y plus 3. Subtract your 3 from both sides to get -3 equal to y. Again, if we're finding an intercept, it is a point, so we need to finish by writing this as an ordered pair. We know the x value is 0, and we found the y value to be -3. So that is our y-intercept. One nice thing about intercepts is that we can quickly graph the equations of lines using the intercepts. Because any line is created by 2 points, there's a line that goes through any 2 points. If you find 2 points on that line, then you can quickly graph them because you just plot those 2 points and you connect them. So let's practice that with this. We know that from our previous method, we were making a table of several points on the line. So this time, let's learn how to graph the equation of this line using the intercepts. Now we found the intercept of our, I don't know where the grid is, of our x-intercept to be 1.5 comma 0 and our y-intercept to be 0, negative 3. So if we go ahead and plot 1.5, 0, and then 0, negative 3, and connect those points, putting arrows at the end of our line. It's important that you all have arrows. That is a quick way to graph your line. All right, so take a moment to practice finding the x and y intercepts of this equation. So pause, and when you're done, click play and we'll check it. Okay, so for, let's see, for our x-intercept, you should be putting 0 in for y, and for, so 0 for y. And for the y-intercept, you should be putting 0 in for x. I like to think of these as the x-intercept is, x is the number, so meaning it's the value that's not going to be 0 usually, and the y-intercept is usually your value that's not 0. So y is the number, x is the 0. That's just a way that may help. So for the x-intercept, we're substituting 0 for y and solving for x. So you should have gotten x to equal negative 2. So we added 4 to both sides, divided by negative 2 on both sides, and simplified to get x as negative 2, 0. And we finished by writing the x-intercept as a point. Finally, and for the y-intercept, we're substituting 0 in for x, not for y, and solving to get y. And we get y to be negative 4. So the y-intercept is 0, negative 4. After you find your x and y intercepts of an equation, you can plot these points and connect them to graph the equation of the line quickly. So we found the x-intercept to be negative 2, 0, meaning we will go negative 2 on the axis and 0 up or down, so staying there, and then 0, negative 4 on the y-axis. Oops. And connect those with arrows at the end of your line. And so that is the graph of that equation. All right, here's another one for you to practice. So find your x and y intercepts and then graph that y equals 4x plus 5 using your intercepts. So pause the video, and when you're ready to check, hit play. Okay, so for the x-intercept, you should have put 0 for y. For the y-intercept, you should have put 0 for x and solved for your different intercepts. So getting the x-intercept to be negative 5/4, 0, and your y-intercept to be 0, 5. Oops. Okay, so plotting these, the y-intercept is up here at 0, 5. And this is the mixed number, negative 1 and 1/4. So it might help to write that mix or that improper fraction as a mixed number to estimate where it's going to fall on the x-axis here. So this is negative 1 1/4, so just past negative 1 on the x-axis, 0. And then connect those points, putting arrows at the end of your line. Here's another one to practice graphing using your intercepts. Hit pause, graph, and then when you're ready to check, you can hit play. All right, for our x-intercept, 0 in for y, simplify. We get negative 7, 0. For the y-intercept, you're putting 0 in for x, solving for y. Oops. And then let's plot these 2 points. So 0, negative 7, and negative 7, 0 are the 2 intercepts there. And that is the end of the lesson for x and y intercepts. I do want to point out one little thing. When we were, let's see if I can get to one. Here's one. When we were graphing equations, we were isolating the y. Notice that with x and y intercepts, you do not have to have y by itself to find your x or your y intercept. You can have it in the format it's given. So that is one nice thing about using intercepts, is you don't have to transform your equation to isolate a certain variable. It is totally fine the way that it's given to you, and you just look for that intercept. So that's the end of that for today.